Hello students, in this lecture we will see some of the applications of ultrasonic waves. Let us see application of ultrasonic waves in engineering. Let us start with the first application, which is detection of flaws in metals. It is non-destructive testing. Without destructing the test piece, this detection of flaws in metals is possible. Ultrasonic waves are used to detect presence of flaws or defects in the form of cracks, blowholes, porosity, etc. in the internal structure of a material. How this is made possible? By sending the ultrasonic beam and by measuring the time interval of the reflected beam. Flaws in the metal block can be determined. So, the waves are sent into the metal and the reflected ultrasonic waves are received. By measuring the time interval of this received beam, flaws can be determined. This is the experimental setup for this flaw detection, which is non-destructive testing. It consists of ultrasonic frequency generator. Where is this generator? Ultrasonic frequency generator. This is the ultrasonic frequency generator, G. And a cathode ray oscilloscope. So this is the cathode ray oscilloscope. This is a transmitting transducer, A. This is transmitting the ultrasonic waves to the metal. And this B is the receiving transducer. B is receiving the reflected ultrasonic waves. These reflected ultrasonic waves are amplified by this amplifier. So this is the experimental setup, which consists of the generator of ultrasonic waves G, cathode ray oscilloscope, a transmitting transducer A receiving transducer B, and an amplifier. This generator generates ultrasonic waves. This transmitting transducer A transmits these ultrasonic waves into the test piece. What should happen? These waves should reach the other end and those should be reflected, and these reflected ultrasonic waves are collected, received by this receiving transducer, and they should be shown here on the CRO, the incident beam and the reflected beam. This is a standard time. Standard time should be there between these two pulses, the transmitted pulse and the reflected received pulse. There should be the standard time. But if some flaw is there, some cavity is there inside, then what is going to happen? This will cause a change in the medium. This is a change in the medium because of the flaw. So the ultrasonic waves, before reaching the end, those will be reflected by this flaw, and this reflected beam will be received by the receiving transducer, and it will show this pulse which is there in between the standard transmitted beam and the received beam. So this is the pulse which shows the presence of the flaw in between. In this way, flaw inside the metal piece can be detected. This method is used to detect flaws in all common structural metals and other materials like rubber, tires, etc. This is a cheap and fast method. So this is first application, which is non-destructive testing to detect flaws inside the test piece. Ultrasonic waves are also used for drilling purpose. The figure shows the schematic of a typical ultrasonic drilling tool. Ultrasonics are used for making holes in very hard materials like glass or diamond also. For this purpose, a suitable drilling tool bit, this is a drilling tool which is attached at the end of the ultrasonic generator. This is the ultrasonic generator and this drill tool is attached to it. Some slurry material. What is a slurry? Is a thin paste of carborundum powder and water. It is made to flow between this tool bit and the workpiece. Ultrasonic generator causes the tool bit move up and down very quickly. So when ultrasonic waves are produced in this ultrasonic generator, it will make the vibrations of this tool bit up and down, fast vibrations with high frequency. And the slurry material which is there flowing in between the bit and the workpiece, it will remove the material from the plate to make a drill into this workpiece. This is the principle which is used in ultrasonic drilling. Ultrasonic waves are also used for welding purpose as shown in the figure. Welding can be done with heating also, but these properties of some metals can change on heating, so that for such metals, heating cannot be the way for the welding purpose. So here the welding can be done for such metals with the help of ultrasonic tools. So in such cases, metallic sheets like here A and B, metallic sheets are welded together at room temperature. They are not heated at room temperature, they are welded by using ultrasonic waves. For this purpose, this hammer H is attached to a powerful ultrasonic generator. So this is ultrasonic generator. This is the power supply to it. Ultrasonic generator, it is a hammer H is attached to this ultrasonic generator. This hammer is made to vibrate ultrasonically. This hammer will vibrate ultrasonically when ultrasonic waves are produced in the generator. As a result, it presses these two metal sheets very rapidly and the molecules of this one metal will diffuse into the molecules of the other. In such a way, the welding is made possible without heating with ultrasonic waves. Such a welding with ultrasonic waves is also called as cold welding. Ultrasonic soldering is also possible for metals like aluminum where direct soldering is not possible. An ultrasonic soldering iron consists of an ultrasonic generator which has a tip at its end. This tip can be heated by an electrical heating element. This tip of soldering iron, it melts the solder on aluminium and the ultrasonic vibrator removes the aluminium oxide layer. The solder thus gets fastened to clear metal without any difficulty. Ultrasonic waves are also used for cutting and machining purpose in the industry. Ultrasonic cleaning is also important application in industry. Ultrasonic waves are used for cleaning various parts of the machine, electronic assemblies, armatures, watches, etc., which cannot be easily cleaned by other methods. Sonar is one of the important scientific application of ultrasonic waves. Sonar stands for sound navigation and ranging. It uses ultrasonic waves for detection and identification of underwater objects. This method consists of sending a powerful beam of ultrasonic waves in the suspected direction inside the water. So here see that the sonar system, it sends the ultrasonic waves in the suspected direction inside the water. It reaches the bottom and then it is reflected back, and this received ultrasonic waves are also received by the sonar system. By noting the time interval between the emission and receipt of beam after reflection, the distance of the object can be easily calculated. The distance of the object can be easily calculated. The change in the frequency of the echo signal due to the Doppler effect helps to determine the velocity of the body and its direction. So, what received signal it is received by sonar system. If it might have some change in the frequency. This is change in the frequency of the echo signal due to Doppler effect. So this change in the frequency of this received reflected signal helps to determine with what velocity that body is moving and in what direction it is moving. So that will be sound navigation and ranging system. By measuring the time interval t between the transmitted pulse and the received pulse, the distance between the transmitter and that object can be determined with the formula d equal to Vt upon 2, where V is the velocity of sound in sea water. The same principle is used to find the depth of the sea. If this is the bottom of the sea, then this is the transmitter, say. So it sends these ultrasonic waves. These are reflected and these are received by this receiver. So if V is the velocity, V is the velocity of ultrasonic waves, and this received signal, received ultrasonic waves are received after time t, say t is the time interval, then this depth of the sea can be determined by d equal to velocity into time. So it is traveling in time interval t. What distance it is traveling? Velocity into time. We'll divide it by 2 because it is going from transmitter to the bottom and then it is reflected back. So what will be the distance from the transmitter to the bottom of the sea? It will be d equal to Vt upon 2, where V is the velocity, T is time. Let us solve one numerical based on this. Calculate the depth of sea if the time interval between the received, between the emitted signal and the echo signal received is 2 seconds in sonar system. Assume that the velocity of sound is equal to 1490 meter per second. So and t is equal to 2 seconds. So we have to obtain depth of the sea. So as we have seen, the formula is d is equal to Vt upon 2. So it will be equal to 1490 into 2 divided by 2. So simply it will be 1490 meters. So thank you, students.